Hey guys, Mr. B here, and in this video we're going to be going over the chapter 1.4 practice problems that are in the notes. So let's start with number 1. Circle the letters of tools that scientists use to organize their data. Alright, so this was in the notes itself, but we organize our data usually with data tables and or graphs. Okay, so just to remind ourselves, data tables are very helpful during the experimenting process to write down and record information. Graphs are helpful after the experiment is over and we want to convey some information better. But either way, both are good ways to organize our data. Number 2, the simplest way to organize data is to present them in a blank. So this would be a data table, though you could, I guess, put also graph, but I'm going to put data table. Okay, it's the easiest way to organize our data. All right. The next one here, number 3, circle the letter of the place on a line graph where the manipulated variable is plotted. So this was in the notes, but we talked about how when you make line graphs, usually your manipulated variable is going to be on the X or horizontal axis, and your responding variable is going to be on the Y or the vertical axis. So this one is going to be C. Okay, the manipulated variable is generally plotted on the x-axis. The run is not really a proper term, so it's like the same thing, but we're just going to select C. All right, number 4. On a line graph, the ratio of the change in the y variable to the corresponding change in the x variable is called the line's blank. So this is the most important part of a line graph, but this is called a line's slope. All right, number 5, circle the letters of the relationships that are direct proportions. So remember, direct proportions are things that when one of them is affected, the other one is affected in the same way. So if one thing goes up, the other thing goes up. If one thing goes down, the other thing goes down. Okay, so let's take a look. Distance traveled versus time at a constant speed. So if we're traveling, let's say 60 miles an hour, okay, and we travel for 1 hour, we'll go 60 miles. So as time goes up by 1 hour, distance goes up by 60 miles. If we travel for 2 hours, now instead of traveling 60 miles, we travel 120 miles. So we've increased time by 2, our distance has gone up by 2. So that means that A, don't mean to move the box here. It means that this one is a direct proportion. So that one is one we can highlight. Letter B, the mass of a substance versus its volume. So as mass goes up, does the amount of space it takes up go up as well? Usually, yes. So the more mass of an object you have, the more space it takes up. Usually. Okay, so we're going to say that yes, this one is one as well, though there may be some corner cases that couldn't be, but I think for the most part that is one. Letter C, the time to travel a given distance versus average speed. So let's say it takes you, an hour to travel somewhere, and your time to travel a given distance. So let's say that we're traveling 1 mile. Okay, we're going to travel 1 mile, and our average speed is 60 miles an hour. Okay, so the amount of time that it takes to travel that is going to be small. If we travel 1 mile and we, instead of go 60 miles an hour, we go 100 miles an hour, the time it takes is now going to go down. Okay, so this one is actually an inverse proportion. If we increase the average speed, so instead of going 60 miles an hour, we go 100 miles an hour or 150 miles an hour, the time it takes is going to go down, right? So as one of those things is going up, the other one's going down. That's an inverse proportion. So C is not a direct proportion. And the last one, letter D, the number of fingers in your classroom versus the number of people. So if we have one person in the classroom, we have 10 fingers. If we have 2 people in the classroom, we have 20 fingers. If we have 3 people in the classroom, we have 30 fingers. So as the number of people goes up, the number of fingers goes up, right? That is a direct proportion. So letter D is also a direct proportion. We'll highlight that one. All right, number 6, true or false? An inverse proportion is one in which the product of the two variables is constant. So an inverse proportion is basically saying, this question is saying, an inverse proportion is one where if you take the two numbers and you divide them, you're always going to get the same number. So it's always going to be like 1 or something. No. Okay? That would be true if it was a direct proportion. For example, 120 miles divided by 60 miles an hour, right? 120 miles divided by 60 miles an hour, that gives you 2, right? We could, whatever, right? That would be direct proportion. If we go 240 miles an hour divided by 120, or 240 miles divided by 120 miles an hour, that's 2. So that's direct proportion, where it's always going to be the same ratio. But an inverse proportion means that the ratio is changing, right? It's not constant. So this would be false. Okay, this is false. You don't have a constant ratio or a constant product. All right. Number 7, identify each data organization tool or organizing tool shown below. So this one, they just want us to basically, that's not what I meant to do. They basically just want us to put down, what type of graph each one is. So A, which is this one in the upper left, that would be a circle graph. So circle graph. B, which is this one here to the right, on the top right, that would be a data table. Data table. The C here in the bottom left, that would be a bar graph. So bar graph. And in the bottom right, this would be a line graph. Okay, so that's all we're doing. We're just labeling what each of these things is. Pretty simple. All right, last questions. Number 8, name 2 ways that scientists can report results of their experiments. This is directly from the notes. So there were 2 ways that we talked about. The first one is scientific journals. And the second one is through speaking at, conferences. So speaking at conferences. Okay. Number 9, true or false? Scientists always interpret a given set of data the same way. No, that is false. In fact, I would be very, very surprised if you could find people who agree on the same data in every single aspect, because it's human nature just to see things differently. So that is false. All right, last question, number 10. Why is peer review an important part of scientific research? Peer review is really important to make sure that the information you're giving out is honest and accurate, okay? And there's no bias in there. So we will say, why is peer review an important part of scientific research? To make sure our results are accurate and honest. Something like that. Okay, so that was the last question in the notes. Hopefully that helped you and cleared up any confusion. But again, as always, if you have any other questions or just want me to go over some stuff with you, email me, talk to me in person in class, or you can reach out. We could do Google Meet or something. But, make sure that you get your questions answered. All right, guys, that's it for this one. I'm Mr. B. See you in the next one. Bye.